In this session of CCNA series, I will discuss REST-based APIs. So what is API? APIs are mechanism that enables two software components or applications to communicate with each other using a set of rules and protocols. And to understand that, let me explain with an example, a real life example of an API. You can think of a API as a waiter in a restaurant who listens to your order, whatever you request, and goes to the chef and then takes the food items ordered and gets back to you with the order. So API, if you compare, is similar to what waiter does. APIs are commonly used to enable interactions between different software systems, allowing them to work together to perform tasks or share data. There are different types of API, which are designed to meet different set of needs, such as web APIs, RESTful APIs, RPC APIs, SOAP APIs, operating system APIs. But actually, the CCNA curriculum mentions only one type of API, that is representational state transfer or REST API. REST stand for, as I said, representational state transfer. REST is not a protocol or standard, it is an architectural style. A web API or a web service conforming to the REST architectural style is called REST API or RESTful API. REST is based on attributes that promotes simplicity, scalability, and statefulness in the design. Those 6 attributes are client-server architecture, stateless operation, clear statement of cacheable or uncacheable, uniform interface, layered, or code on demand. Actually, the first 3 of the 6 gives you the idea of how the rest works. So we'll focus only on that right now. So let's start with client-server architecture. REST-based APIs are based on client-server architecture, where clients and server are separate and communicate over the network. The client can be any device or application that can make HTTP request, while the server is the application that provides the API and responds to the client's request. Another attribute is stateless operation. REST APIs are stateless, which means that each request from a client to the server contains all the information needed to process the request. The server does not maintain any client state between the requests. So it's a one way. So client, it doesn't maintains any state. That's what I mean. Clients can request resources in any order, and every request is stateless or isolated from the other request. The other important attribute is cacheable. REST APIs can be designed to support caching, which can improve performance by allowing clients to reuse previously fetched resources. Like when you are browsing any website, your client, on the client on which you are working on, it caches the content. This is somewhat similar to that. So APIs exist, as I said, to allow two programs to exchange data. Some APIs are intended to serve as interface between programs running on the same machine, enabling communication within a single operating system. And for the APIs which are running on separate machine along with the REST APIs, a network protocol is required. Okay. So a RESTful API uses HTTP protocols for this purpose to enable communication between two APIs on separate machine. So it uses HTTP protocol for communication. So HTTP, actually, why, the question will come into your mind, why REST API uses HTTP? HTTP wasn't created specifically for REST. Rather, REST adopted this communication protocol as the standard for the applications that use it. And HTTP logic matches some of the concepts defined more generally for the REST APIs. HTTP aligns well with the attributes of REST, such as it operates with a client-server model. It uses stateless operation model. It includes header that clearly marks object as cacheable or not cacheable. It includes verbs, which we'll be further discussing. Uh, it includes verbs or methods, you can say, that dictate the desired actions. So before we go and discuss that, let's look at some software action called CRUD and how that matches with HTTP verbs. If you are a computer engineer, I'm sure you might have heard about this CRUD. In software development, CRUD actions are common operations performed on resources, that is data. And CRUD stands for create, read, update, and delete. It refers to the four basic functions that are commonly used to manage data in the database or application. Starting with create, this action is used to add new entries into the database, such as new instances of variables and data structure in the server. For example, in a web application, a user might fill a form to create a new account, and the application would insert the user information into its database. This is done using create action. Then we have the read operation, which involves retrieving data records from the database. It retrieves data from the database. It allows the client to retrieve, that is read, the current value of variables that exist in the server. So read is meant to serve the user with information which is already existing in the database. Then we have update action. The action verb is used when we want to alter existing variable values in our database. Like it allows the client to change or update the value of variable that exists at the server side. For example, in social media application, user might update the profile information such as their bio or profile picture. Then we have delete. The delete operation involves removing data records from the database. It allows the client to delete from the server different instances of data variables. For example, in e-commerce application, a user might delete an item from their shopping cart. So this is one of the example for delete action. Now, if you think of a scenario of a DNA controller and it is using northbound REST API, these actions I would like to explain, like for example, to create something new, like a new security policy or new configuration at the controller is performed via the API using create action. Similarly, to check the status of that new configuration, read action is used. And to change some specific settings in the new configuration, an update action is used. And to remove the security policy definition completely, a delete action is used. So these are the CRUD actions when you apply it on the DNA controller. So let's go ahead and compare HTTP verbs with CRUD terms. Like for example, create action is used to create new resources, right? And the term which CRUD uses is create. And in HTTP, the corresponding verb is post. So create is similar to post. Similarly, read action is used to retrieve an existing resource. In CRUD term, it is read, and in HTTP, the corresponding verb is get. Similarly, update action is used to update an existing resource. In CRUD, it is update, whereas in HTTP, the corresponding verb is put or patch. And lastly, the delete action is used to delete an existing resource. In CRUD, it is delete, whereas in HTTP, the corresponding verb is delete. So I hope this comparison is clear for you guys. So with that, let's move on to another topic, URIs. In addition to using HTTP verbs to perform the CRUD action for an application, REST uses URIs to identify what resource the HTTP request acts on. A URI, also known as Uniform Resource Identifier, is a string of characters that identifies a specific resource. So with HTTP, URIs are used in requests to specify the resource that a client wants to interact with, and in response to to indicate the location of the requested resource. For REST API, the resource can be any one of the many resources defined by the API. So each resource contains a set of related variables defined by the API and identified by the URI. For instance, imagine a network admin creates a REST-based API. Here the admin creates a set of resources that he wants to make available via the API. And he also assigns a unique URI to each resource. So in other words, the API creators create a URI and matching set of variables and defines the action that can be performed against those variables, such as read, update, and so on. So let's look at the general format for a URI structure in a RESTful API GET request. The general format is this. In this structure, HTTP specifies the protocol, whereas the API after 2/api.example.com is the domain or host name of the API. And the URI specific to Cisco before that resource is the path that indicates the type of resource being requested. So these are the three important contents of the URI structure. So if you look at the URI specific to the Cisco DNA Center Northbound REST API, this is an example. Here you can see there is a protocol, there is a host name, and then there is a path for that DNA center. I hope this was informative for you. Thank you for watching. If you have any queries, please do let me know. I'll be happy to help you guys.